joining us is Thorsten Stremlau. He's he's systems principal architect and distinguished engineer at Nvidia. And I'm really excited because he's going to be talking about opportunities that CORA could help fulfill for the remote work and play industry. So take it away, Thorsten.
Thank you, Neil. You can see my screen?
Yes, I see your screen.
Okay, very good. All right, just checking. All right, everyone. After the great introduction by Neil and also further elaboration by John, I'd really like to go onto a little bit more of a technical tangent or a little bit more explanation in terms of what we're thinking about around what CORA can do for the remote work and play industry and the approach that we're going to be taking or that we're taking around a lot of these different types of things, and also go a little bit into the history, more on a technical basis than anything else like that. So number one is I'll talk a little bit about the evolution of computing. John already talked a little bit about VDI and computers and clients and servers, et cetera, et cetera. I'll dig a little bit deeper into Triparity, something that Neil mentioned in the beginning. So what is the Triparity Initiative? And then hopefully in the last couple of minutes, talk to you at a very high level, very high level. I don't want to go into too much detail in terms of the maths that are involved in the exact telemetry data and how we're planning to handle it. At least give you a good understanding of the framework that we're working on around Triparity Initiative as part of CORA and how we plan to deliver better work and play with that framework. Okay. So looking at the evolution of computing, and John mentioned this very briefly. Unfortunately, and you can tell from the gray in my beard, is I do remember times where dumb terminals were used to access mainframe applications. Not too much different to what VDI compute could be or can be construed at these days, right? And over time, the computing evolution then went into desktop applications, right? We saw DOS, and well, previously a couple of other iterations, but then moving to Windows 3.1 or even earlier versions of that. Then Windows NT, for example, brought in a lot more client-server applications. And then obviously there are a whole bunch of other iterations that went into internet website hosting, internet applications, and then looking at cloud-enabled applications, right? And these are applications that really make use of or host some of their compute categories in the cloud. Now, in the chart that you can see there that's wildly fluctuating, one of the things that I've tried to do is kind of show that there's ups and downs to each of these. So typically, by the way, and we're going through some of this again right now post-COVID, is server-side compute has its ups and downs in many different places. Sometimes new technology developments will drive more of the compute to servers. Same thing for client. And client fluctuates a whole bunch faster than the server-side compute. Now on VDI, and John mentioned this in the beginning, VDI has some slight fluctuations, but I do have to say is that the adoption of VDI in the traditional sense has remained kind of static. It does fluctuate a little bit, but not as much as the other two. Now there are some dramatic changes in this technology that may see a much higher adoption that we'll talk about a little bit later on today. But you can see here, this is basically the evolution of computing from a server side, client side, and VDI compute. On the evolution of computing itself, and I by the way, I tried to stay away from Nvidia logos as much as possible. But a lot of things started, and I challenge any of you to identify the first chip that's under CPU. But in terms of the way that computing itself has evolved, it all started with a CPU. Then all of a sudden, people identified, wow, if I have a dedicated GPU, then I can offload some of my graphics processing onto that, and then get additional performance. And there's a new trend, a very big trend, and a very successful trend to now also go into specialized DPUs or data processing units. that are highly optimized to a particular category. In this particular case, you can see a Mellanox Bluefield DPU, which is a network offloading a DPU. But still, what we can see here is much of it is in either the CPU space, in the GPU space, or now in the newly defined or newly evolving DPU space. And processing nearly always, not always, that's why I put nearly always occurs in these isolated pillars, right? So, on the CPU, you'll have a process with all these different types of threads, and different types of processes with different types of threads. And then basically the CPU pipeline then has these different threads lined up, and sometimes they can be out of sync, or they can be out of sequence. And there's some idle time in between processing each of these. And there's, by the way, there's whole optimization algorithms that are there just to optimize the CPU pipeline. GPUs typically are much more optimized for graphics. And one of the things that is actually one of the benefits is its ability to organize the threads in a GPU pipeline much better, so that the processing in many cases happens a little bit more efficiently. And DPUs, by the way, same kind of thing. I just wanted to keep that in there. But typically today, when we take a look at these different types of compute environments, they're still happening in isolated pillars. Now, we are seeing new types of technology come up, right? So, and I'm just going to mention here, if we take a look at the Apple M1 and M2 processors, and what Apple's done there is by introducing performance and energy efficient cores. Right, one of the things that Apple has managed to do very, very successfully is that they're able to determine where it's best to process a thread or process slots, whether it's in the efficiency cores or whether it's in the performance cores, and that delivers a lot of performance increase, but then also, very importantly, a lot of energy efficiency, right? And by the way, this is just an example chart that I pulled off of the internet, just to show a little bit about some of the ways that's handled. By the way, that algorithm that you can see there that Apple has implemented on the M1 and M2 chips is not very easy, right? This chart that you can see here actually adds a lot of complexity. But by the way, this is just an example. I want to be very, very clear. The industry is moving to better scheduling of processes and splitting into performance and efficiency cores, because it's recognized as being the best way forward, right? It's so that's one of the new things that we've got. But again, it's kind of limited to just CPUs in that particular case, or SoCs. Now, on the other hand, there's also many advances that are being done in graphics, for example. This is one example of enabling something that's called threaded optimization, for example, on a graphics card of a manufacturer that I'm not going to name. But anyway, you can see here that by implementing a special function here in the graphics called thread optimization, I can also really accelerate the performance of the graphics card. Now, there are many different organizations that are dealing with optimizing cloud processing, interoperability, manageability, security, and portability, all these different types of areas. And I've just listed a couple here. If any of you are interested in looking at those different orgs, Oasis TIFCA is one of the ones that we can see there. OMG has a cloud standard that's all about, as I said, interoperability, manageability, and security. And then DMTF has also started a cloud management work group to define standards in this space. So in the cloud, especially because of the nature of the cloud and because of the nature of the compute in the cloud, a lot of different organizations have already started looking at optimizing and making hybrid cloud solutions more performant, easier to migrate across, and also enhancing security and portability, as I said before, right? So that's something that's been there. But again, I just wanted to highlight, it's still very much in a silo, right? So we have cloud compute or server-side compute, we have the client compute or CPUs, and then we kind of have the graphics compute, or in those different types of things. And as Neil said all the way in the beginning, something that's fairly important here is that those are the different types of things that we're working on to optimize as part of CORA, right? So it's create once, reach all is one of the things there, and that encompasses both cloud and also the client devices. And as part of that, Neil mentioned the Triparity Initiative, or client, cloud, and network. So that we've done a lot of different work, and we've sat down and argued and come up with a framework that we want to drive into the industry as part of CORA to help optimize the user experience, right? Again, John mentioned if I have a workstation, that's great. Then I could do that processing power locally, and if I don't, then I can do a lot of that in the cloud. But what if I was able to blur that line? What if I was able to establish, you've got a pretty good graphics card. Your CPU may not be that great, but your graphics card is really good. I'm going to make use of your local graphics card a little bit more. And by the way, we are seeing this. We are seeing this in many, many different areas. So for example, from a Microsoft Teams perspective, that's one of the things that Teams is able to do, is for audio compression, decompression, and some other functions, is to actually leverage the capabilities of the local device in order to make that Teams experience better. But those, as I said, are some of the different things that are there. And from a Triparity Initiative, as part of CORA, we're looking to drive that framework into the CORA ecosystem, right? That's something that's very, very important, and something, as I said, that we've been working on for quite a long time. So what exactly is Triparity, and what are we trying to do here, right? So on the one hand, the framework is there to break down the client cloud processing pillars, right? So it's obviously very, very important to understand, if you're trying to do this, to understand what are the capabilities of the client, right? And I put a couple down here. So for example, the CPU, how fast is the CPU? How many cores does the CPU have? What kind of graphics card does it have? How much memory do you have? How much, how fast is your storage, your SSD? How fast is your network card, and what's the connectivity? What's the utilization? And also very important here is, what's the security status of your device, right? Is this your son's gaming PC that's riddled with viruses, or is this a PC that is more trustworthy and maybe has some enterprise security features built in, or is it a particular level of operating system that is patched, et cetera, et cetera? Another thing that's important here is the network, right? So looking at latency, jitter, packet loss, and all of the typical things that we use in order to measure the reliability of the network, right? And these are all things that are really important to understand if you're trying to optimize the connectivity. And lastly, is kind of like on the cloud, but obviously a little bit different, is what are the cloud measurements, right? The cloud telemetry data, right? So what's the cloud environments or ecosystems uptime and availability? What's the CPU utilization, memory utilization, et cetera, et cetera. So if I'm able to understand the different variables and how they influence the processing of an application, regardless of if it's running primarily on the cloud or running primarily on the client, the premise of Triparity is that I can then share the load where it makes sense, where it makes most sense to process, right? And so by gaining a detailed understanding of the capabilities, Triparity, as part of CORA, is looking to optimize the process contention scope and the system contention scope in order to make better use of all of those different types of things that are available to me as the end user on the device, right? And to dig a little bit deeper, just a little bit, don't worry, not going to go too much, but for example, this is something that's commonly done in the Lagrange multiplier environment. It's a mathematical tool where you can now basically, well, you can interpret all of these different types of environments. You can generate a very, well, I'm not going to call it a simple function. It is definitely not a simple function, but by introducing the constraints 1, 2, and 3, client, network, and cloud, that is part of Triparity, I can now go through and I can basically do some contention scope optimization by now understanding where does it make most sense for me to process this particular thread or task that I've been asked to do. Does it make sense for me to send X amount of data across the network to be processed in the cloud? Or should I just keep it locally? Or the other way around, does it make sense for me to offload cloud capabilities onto the local client? Or is the client just going to generate even more problems? And so, the thought here is that still, and by the way, I am still operating in this particular drawing, in this particular graph in pillars. So apologies. I do want to look at developing and being able to cross pillars with the offloading of threads. But let's say, for example, this is my normal CPU pipeline that I have in here. And then a Triparity enabled CPU pipeline would process all of the orange threads first, and then it would determine, you know what, in this time, in these 3 little idle states, or also in this entire time, it might make sense for me to send the red threads across to a cloud CPU environment and have them process and return it, if that's what makes sense, if the security makes sense, if the throughput makes sense, et cetera, et cetera. I might determine as part of that the GPU pipeline makes no sense to me for me to transfer. Or by the way, I might. And then the other hand is as well, it might make sense for me to offload, for example, certain DPU capabilities from the cloud back onto the PC, right, in order to fill any kind of idle states that I have on there. And that's exactly what we're trying to do with Triparity as part of CORA, right? So when you take a look at CORA with Triparity, on the one hand, we're engaging with CPU, GPU, DPU, and NIC partners in order to integrate the necessary telemetry into their at hardware level, right? This does require some telemetry at hardware level. We're obviously looking to leverage existing technologies in operating systems and drivers. For example, just for legacy apps, none of you are going to rewrite applications in order to make use of all of these different types of things. But as part of CORA, we also want to create a standard that enables Triparity capabilities for new applications, so that applications are also aware of the different environments and can take those constraints into account and do some pre-ordering, right? That's typical in fashion. In the network space, drive the adoption of the Triparity network framework, right, to optimize contention scope and get better information. And then lastly is work with all those, well, not just all those, but some of those, or maybe all of them, cloud standard bodies in order to integrate the Triparity initiative and extend the hybrid cloud capabilities, right? So in a nutshell, what we're seeing here is, this is Triparity with CORA and the work that TIFCA is doing in order to drive these new standards, into and to really optimize performance, right? That's basically it. So, looking at this, we still need a lot of help. There are many open items that we're still discussing. Areas around security. How do I now make sure that if I transfer a particular process to the cloud or to the client, that process is still very secure? How do I handle virtualization? And then another very big topic is the enabling of legacy applications. How do I do that in a way that maintains compatibility with that application that's now 13 or 14 years old, but it's still running in my enterprise environment, right? I have to say is that working with Neil and also with John, we already have many leaders in this space on board, and many of you have also dialed into this call today, right? So it's a pleasure to have you here. But call to action here is really look at TIFCA, join TIFCA, and then see what we can do together in order to optimize this space and really blur the boundaries between the traditional pillars that we have today. Okay. So with that, Neil, I'll hand it back over to you. And thank you, everyone, for listening to me and taking the time.
That was tremendous. Thorsten, I really enjoyed your presentation. I know we're talking about remote work and play as an industry. We're talking about CORA as an ecosystem and this Triparity Initiative. This is nothing less than world-changing stuff. And it will be amazing to see this go further into fruition with more industry engaged, because I really see a strong future with this. So thank you, thank you, thank you.